So this is the third session of the P6 unit for OCR 21st Century Science on radioactive materials or physics. So in the first session we looked at the structure of the atom. In the second session we looked at the idea of isotopes and the idea that some isotopes are unstable, their nucleus tends to try and break up, and that nucleus will decay and give out some particles. So what we're going to look at in this session is what kind of particles can be ejected from a decaying nucleus. So we're going to look at radioactive decay, and we're going to particularly concentrate on one of the three types of radiation that are released. There are three types of radiation that can be released from an unstable nucleus. There are alpha particles, normally given the Greek letter alpha. There are beta particles, Greek letter beta, or there are gamma rays, and you should be familiar with gamma from the unit that you did on the electromagnetic spectrum, which is given that symbol. So when a nucleus of an isotope is unstable, it can decay, and as it decays into its daughter nuclei, it can give out alpha, beta, gamma, or a whole combination of those three. So we're going to look particularly on this session at alpha decay, and we're going to examine the properties of alpha particles. So as you remember from the first session, it was alpha particles which were used in the experiment to probe the gold leaf in the Rutherford-Geiger-Marsden experiment. So let's have a look at what happens when an alpha particle is released. So let's take the example of plutonium. So plutonium, which is plutonium-240 94, will decay into a completely different element, which will be uranium. Now uranium 92 236 is what it decays into. Now to give you the equation version, you can see that I've got 240 particles in the nucleus, and then once it's decayed it's gone to 236, so I've lost 4 particles. And if we look down here, it's gone from 94 to 92. So what we can work out from there is that what must have been lost is 2 protons and 4 particles altogether, and we call that an alpha particle. So an alpha particle is made of 2 protons and 2 neutrons. I'll colour in the neutrons as dark, but it really doesn't matter. Okay, so that is an alpha particle. Now an alpha particle is ejected at high speed from the plutonium as it decays. Now this is a random act, you don't know which nucleus will decay and when, so you can't really predict which ones are going to decay, but if they decay and give out an alpha particle, then the plutonium becomes uranium 236 and an alpha particle is ejected. Now in these equations you have to make sure that the sum of the particles on both sides matches. So 94 is the same as 92 plus 2, 240 is the same as 236 plus 4. So that's a balanced equation. So let's have a look at the properties of alpha particles. So alpha particles, because they are so large with a high positive charge, it means they don't travel very far in air. In actual fact, they have a range of only a few centimeters in air. Now the reason that their range is a few centimeters is because they make lots of collisions with molecules in air, and as they do so they ionize them. Now as you remember from P2, ionizing means that they can remove electrons, or they can charge an atom in some way by knocking out electrons, and so, or they can gain electrons from other places and just turn into helium. So alpha particles particularly, they bump into atoms, steal their electrons effectively, and turn into helium gas. Because if you add 2 electrons to this, it just becomes a helium gas. Because remember, an alpha particle is the same as a helium nucleus. So because they're so large, they make lots of collisions. Because they make lots of collisions, they lose their energy quite quickly, so they don't travel very far. Now, they can be stopped very easily, and they are stopped by a piece of paper or just your skin. So alpha particles can't get through your skin and can't really damage you on the inside if they're aimed at you. And also, if they're more than a couple of centimeters away from you, then the radioactive source giving out the alpha particles, those alpha particles won't travel more than a few centimeters. So if you're in danger from alpha radiation, you can just simply step away. 1 step will be plenty. The fact they can't get through your skin means they can't damage you in that way. The only way they can really cause you damage is if you inhale them, and then they are inside your body and they can contaminate you. So don't travel very far, and they're stopped by paper or skin. Their charge is positive, and their ionizing power is very, very strong. Now these factors have to be remembered. So these are just pure facts to remember. I think you can get most of the facts from the fact that this is a big positive charged nucleus. So it doesn't travel very far because of its strong ionizing power, and therefore it doesn't travel through much. Okay, so that's alpha particles. Now alpha particles have lots of uses, particularly in smoke alarms, and we'll come back to uses in another session.